In this video we have another trig identity to prove. So again, we start either with the left side or the right side, whichever one you want. Normally you want to pick the more complex side, because if you look at this, let's say we want to go from the right to the left. 2 cosine squared of x. How do we get all of this? It can be done, but in general we start with the left side, or the more complicated side, and that's the left side here. So I got 1 minus tangent squared of x over 1 plus tangent squared of x. Then we got a plus 1 here. And you wanna, this is our objective right here. That's what we want to get after simplifying this. So let's go ahead and write this as one expression. So let's just combine this. Lowest common denominator here is 1 plus tangent squared of x, and this will be 1 minus tangent squared of x here, and then we can write this as 1 over 1 and multiply numerator and denominator by 1 plus tangent squared of x. So I have the same denominator now, so I can just write it this way. So that's what we have. Now again, just got the same denominator here, multiplied by 1 plus tangent squared of x, 1 plus tangent squared of x, and this is what we get. Notice the tangent squared of x and the minus tangent squared of x cancel, so that'll give us 1 over 1 plus tangent squared of x. But looking ahead here and looking at what my objective is, notice I have to come up with a cosine squared. I'm not going to do it with tangent, so let's rewrite that tangent squared. So always be looking ahead to what we have to get. So eventually I have to get a cosine squared, actually 2 of them. So that's what we get. And then this is clear with the fractions. So I'm going to multiply the numerator and denominator by cosine squared. So let's just do it mentally. Multiply the numerator by cosine squared. That puts the cosine squared here. Cosine squared of x. Okay, I'm multiplying by cosine squared. And then the denominator multiplied by cosine squared, well, it's going to be 1 times cosine squared will give me a cosine squared. And on this one I forgot the 2 here. This is 1 and 1. This is a 2 here, not a 1. So let me rewrite this. So this was a 2 here. Minus tangent squared and plus tangent squared canceled, so I get here, then this was a 2 then, multiplied by cosine squared, so this is a 2. Okay, notice we have a 2 cosine squared. We already have the 2 cosine squared here. Then in the denominator, the 1 times the cosine squared is cosine squared, and then when I multiply the sine squared x over cosine squared x by cosine squared, the cosine squared cancels, and that leaves me with sine squared of x. And this is where you have to recognize your identities. We know that cosine squared of x plus sine squared of x, or the other way around, sine squared of x plus cosine squared of x, this is 1. So all that gives me then is 2 cosine squared of x over 1 is 2 cosine squared of x. And that's what we wanted to get. Those are the results. And that is the proof or the verification for this particular identity. Notice you could go the other way around. You just reverse these steps. And notice if I wanted to go and prove this using the right side, I would start with 2 cosine squared of x. But then, okay, how did I get this? Well, I can put this over 1, and then what? Well, I know that 1 is equal to cosine squared plus sine squared right there, and then I keep going. But in this case, like I said, generally it's easier to start with a more complicated side and get the other side. So in this case we got 2 cosine squared of x. Thanks for watching. We'll see you next time.